Okay, everybody, grab some paper. We're doing the basics of trig. Okay, we're only going to handle right triangle trig. Okay, right triangles. We need 90 degrees. That's the only kind we're going to do. In order to get through this course, you have to know this. If you're an old hat, great, go along with this. I expect everybody to be writing down as I go. All right, so this is going to be example 1. I got my TI-84 handy. You need to have it handy too. All right, we're starting with this triangle. I'm going to make it kind of big. You do not have to make it this large. This is my 90 degree. This is 4. This is 5. Those are the legs of our triangle. The longest side is hypotenuse. This should be review. My angles, we like to use Greek letters. I'm going to use alpha, like a Jesus fish, but not really, and theta. So basics of the triangle. Hypotenuse is longest side. The sum of these two sides will always exceed that side. All three angles added up make 180 degrees. Since we're doing right triangles, I can subtract off that 90, and remember, these two will always add up to 90. So let's talk about the basic functions. Sine, cosine, and tangent. These are relationships that literally take into consideration these angles and these sides, and the ratios of them tell us a lot about the triangle. Sine of an angle is always the opposite over the hypotenuse. I'm abbreviating. The cosine relationship always looks at a triangle and looks at the adjacent over the hypotenuse. Tangent is always opposite over, that's an A, adjacent. Some people say so, ka, toa, to help remember these. So we're just going to do some basics. Looking at the relationships. If I'm in this part of the triangle, 4 is adjacent, 5 is opposite, as if you went across. But that changes if I come over to the other angle, the other side. Opposite is now 4, adjacent is 5. Let's start with finding the hypotenuse. Well, we should already know Pythagorean theorem. A squared plus b squared equals c squared. All right, so let's do 4 squared is 16, plus 5 squared is 25. I want the square root of 41. I'm going to ask you to go to decimals. All right, second square root, second answer. If you didn't know how to do that already, put that in so you don't have to type it. 6.40. So that's a pretty easy, that's a review. So now I have 3 sides and I can look at the relationships. So we're going to do a little bit more than just figure stuff out. So I'm going to start with sine and alpha. The sine of alpha is the opposite over hypotenuse. Well, here's alpha. Opposite is 5. Hypotenuse is 6.4. Cosine alpha. Staying with alpha. It is adjacent over hypotenuse. So adjacent is 4 over 6.4. Tangent of alpha is the opposite over the adjacent. So that's 5 over 4. So these are just relationships. I mean, 5 over 4 is 1.25. It's just a number. But that's the tangent of it, not the actual angle. So let's look at theta. Okay, well, if I do sine of theta, well, opposite is now 4 over 6.4. If I do cosine, I'm going to move this up a little bit, of theta, well, theta is here, cosine is adjacent, it's 5 over 6.4. And lastly, tangent of theta. Hopefully your writing's neater than mine. Well, it's 4 over 5. Again, relationship. Notice the tangent. See what happens? They're inverse. Also notice what happens here with sines and cosines. See the flip-flop? This sine becomes this cosine. It's only 3 sides. There's only so many relationships. So how do you use these to figure out the angle? This is where the calculator comes in. So I'm going to clear. The way it's written, in order to find this alpha, and yes, I'm going to find it 3 times. I know you won't have to do it 3 times, but you could. We write it like this. Sine to the minus 1 of 5 over 6.4 equals alpha. if we were going to use this one, cosine minus 1 of 4 over 6.4 equals alpha. Tan minus 1, 5 over 4 equals alpha. So this is 3 ways I can find this out. So here I go. Okay, to get that minus 1 on my sine, I'm going to hit, I'm going to move this up a teeny bit too so you can see it better. Second sine, and I'm going to put 5 divided by 6.4. Oops, I hit times. Let's do that right. Divided by 6.4. There we go. Now I know that alpha is 51.3. We're going to go 2 decimals now, degrees. So let's do this one. Second cos, and I'm going to put 4 divided by 6.4. I'm going to get alpha is 51.32 because that 7 is going to round. Okay, let's do the last one. Second tan, 5 over 4. And I get that alpha is 51.34 degrees. Don't forget your units. Okay, so I'm doing this the long way. You would only have to find one of these, but the point is you and somebody else might get slightly different answers, but they're good for what we're doing. Okay, let's find this. Well, we could do this really easy. I know alpha's around 51.3. I could just simply subtract it from 90, but I need you to practice. So in this one, sine to the minus 1, 4 over 6.4. Make sure you're practicing on these calculators as you write these down. Cosine minus 1, 5 over 6.4. And these equal theta equals theta. These are equations, by the way, so you have to work the sides just like you would in any other thing. Tangent minus 1 of 4 over 5 will equal theta. So let's go through the math. And this is calculator practice. All right, second sine, 4 divided by 6.4. I did it again. Second sine, 4 divided by 6.4. All right, I'm getting that theta is 38.68 degrees. Okay, second cos, 5 divided by 6.4. Theta in this case is 38.62 degrees. Second tan, we have 4 divided by 5, and I get theta is equal to 38.66 degrees. Okay, if you're using the minus 1, that means you're finding an angle. Okay, now we're going to go to a new example. I'm simply going to flip my paper over, and this is going to be example 2. Remember, this is a video. You can stop and replay at any time. All right, so example 2. All right, draw a little triangle. I'm going to draw it big. You don't have to draw it that big. Here's my 90 degrees. This leg is 3. This is side B, and this is side C. This is angle alpha, and this is 35 degrees. I simply want to find what alpha equals. Sorry, don't make it look like a 2. C and B. Those are the things I want to find. So let's see what the best method will be. I'm going to keep my calculator so you can see me doing the math. Well, first of all, we know these two add up to 90. So 90 minus 35, that's done. Alpha is done. It's 55 degrees. Now, when I approach these, I will never, unless I have to, use a calculated value just in case it's wrong. I will use given values. So now I have to think about SOHCAHTOA. And what would I use? Well, I have 35 degrees and I have the opposite side. So right away, boom, cosine is out. It doesn't have an opposite. If I use the 35 and the opposite and C, that means I have to use sine. When I use 35 and the opposite and B, because it's adjacent, I have to use tangent. Okay, so let's do those. I'm going to use the sine one first. So I'm setting up an equation. Sine 35 degrees. You know, we know the angle, so there's no minus 1, equals opposite, which is 3 over C. Now, we're going to solve to get C by itself. I'm going to times both sides by C. That cancels. And then I'm going to divide by sine of 35 on both sides. So C equals 3 over sine 35. All right, on my calculator, I'm just going to take 3 divided by sine. No minus 1. We know the angle. 35 equals. So C equals 5.23. We don't have any units in here. I'm not going to go crazy with that. That one's done. So now we can use tangent. I know you could do Pythagorean theorem, but the point of this is to learn the trig. Okay, so let's use tangent. Tangent of 35 equals, okay, it's opposite, so it's 3 over b. So look at here. Whenever the variable's in the bottom, we can do all this cross multiplying, but essentially we end up with like this, okay? You can multiply, I'm going to do it just so you see it, times both sides by b, that cancels, divide by tan 35, that's going to cancel. So b is going to equal 3 over tan 35. Okay, so let's do it. 3 divided by tan 35. There you go. B is 4.28. 4.28. Double check. Is C the longest side? This is 3, this is 4.28, this is 5.23, this is the hypotenuse. That makes sense. Okay, we're going to go to a new page. All right, this is going to be example 3. And again, stop at any time, pause, and slow this down if you need to. Okay, example 3 is my favorite triangle. You will see this later in the unit a lot. Okay, side A, side B. My hypotenuse is 18. This is theta, and this is 50 degrees. I call this triangle the Lieutenant Dan triangle. Wonder why. Let's see. I need theta, I need a leg, and I need a leg. Lieutenant Dan, you got no legs. That's why this is Lieutenant Dan. Okay, so let's do this. We could do this in our head. These two have to add up to 90. 90 minus 50, 40 degrees. Done. I'm going to keep track of my toa. So I have 50 degrees and I have a hypotenuse. I'm not going to use tangent. I don't have a hypotenuse in there. So if I use the sine, that will get me the opposite side with the hypotenuse. And if I use cosine, it'll get me adjacent. So let's set it up. Sine of 50 degrees equals A over 18. Well, this is quicker than the other ones. All I have to do is times 18. I'm going to scooch this a little bit. Times this by 18. Those are canceled. So all I have to do is solve 18 times the sine of 50. Okay, so 18 times sine 50. Enter. Looks like A equals 13.79. Again, no units. Let's see, that was sine, so now use cosine. So cosine of 50 degrees equals adjacent B over 18. Works the same way. Times by 18, times it by 18. This goes away. So I'm going to do 18 times, oops, me and my cosine 50. Boom. 11.57. Those are both less than 18, so I know I didn't mess up. That's my Lieutenant Dan. Okay, let's go to the last one. I have example 4. I'm going to turn this over. Something I should have told you before. Let's hope you're getting it right. Hopefully you're not frustrated. Let's go to mode. And I'm going to put this in the center for a moment. And notice if you're not getting these numbers, you could be in radians. So if you were, I'm going to go down and hit enter. Now I'm in radians. If you were, you would go to degree and hit enter. Okay, that's pretty much the only thing you want to make sure you're always in degrees. We do not use radians. Save that for math. Second quit. Okay, so we're going to do this last problem. This is example 4. All right, last problem looks like this. Again, you don't have to draw them as big as I do. I'm doing this so you can hopefully see them better. It's a 90-degree triangle. This is side A, this is 4, this is C, this is 20 degrees. Okay, well, we need, oops, what are we gonna call this? This is theta. So we need theta, A, and C. Well, theta's pretty easy. I can do that in my head, right? 90 minus 20 is 70 degrees. And I'm not saying you can't use the 70 in your calculations. You're perfectly welcome to do that. I choose to use what's given so that I don't misuse an answer that might be wrong. All right, so I'm going back to SOHCAHTOA. SOHCAHTOA. So look, I have an angle and I have the 4. 4 is adjacent. Adjacent and adjacent. Guess what I'm not using this time is sine. All right, let's use cosine. Cosine of 20, since I have the angle, equals adjacent, which is 4, over the hypotenuse. There's the c. Same thing. Times by c. That's going to cancel. Divide by cosine 20. You end up with c equals 4 over cosine 20. Okay, here we are. 4 divided by cosine 20. There we go. I'm getting 4.26. I'm just going to put up here. And that was my cosine, so now I'm going to use the tangent. Make a little bit of a mess here. Tangent of 20 degrees equals opposite, that's a, over the adjacent, which is 4. This one's the easy one. Times it by 4 on both sides. Boom. Okay, so 4 times tangent 20. I'm getting 1.46. And again, there are units. Some things to always check because these are easy to get mixed up sometimes. If this angle is 20, this angle is 70, the rule in a triangle is the side opposite the bigger angle will be the bigger side. So this one was 4, this was 1.46. This is 20 degrees, it's small, this side should be small. This side is 70, this side should be bigger. And of course, the hypotenuse should always be the biggest. Okay, make sure your mode is set. Replay any of this and slow me down if you need to. Those of you that are good to go. We're going to do some more practice on your own. Peace.